Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. This is the story of how I became interested in the Carolina Bays and published 2 books about them. After retiring from a career in chemical information and computational linguistics, I started taking some online courses in geology, astronomy, and paleontology, which had always interested me. At that time, I was also starting to use Google Earth to look at the surface of the Earth. I had read that people had discovered impact craters from the satellite images. One day, when looking at the terrain of Niger, I came across the Ayer Mountains, which have very interesting circular structures. This looked to me like a field of impacts made by the disintegrating comet. I had already come across a program that calculated projectile size based on crater diameter from the University of Arizona. The calculations were based on Professor J. Melosh's book on impact cratering. I wrote a description of how the extraterrestrial impact could have happened, and the description became part of my ebook Meteorite Cluster Impacts, published in 2012. Soon afterwards, I came across the Carolina Bays, and I found Michael Davies's website containing LiDAR images of the bays. His website also had a map showing the convergence of the major axes of the Nebraska rainwater basins and the Carolina Bays at Saginaw Bay. I had already read the papers by Richard Firestone proposing that an extraterrestrial impact or airburst over the ice sheet that covered North America 12,900 years ago was responsible for the megafaunal extinction and the creation of the Carolina Bays. The publication of a Requiem paper by Nicholas Peintner in 2011 basically stopped all research on the Carolina Bays by professional geologists, and this was the time when I started looking at the Carolina Bays in detail. I assumed that the convergence point calculated by Michael Davies was covered with ice and that a meteorite impact would have ejected boulders of glacier ice. I started using spreadsheets with ballistic equations to calculate the speeds needed to launch the ice boulders toward North Carolina and South Carolina. The ballistic equations also enabled me to calculate the time of flight and the height reached by the trajectories. It took me several days to fully understand the implications of the calculations. The launch speeds were in the range of 3 to 4 kilometers per second, which is about 11 times the speed of sound. The heights of the trajectories were from 150 to 370 kilometers above the surface of the Earth. A few days later, I realized that the atmosphere only reaches to about 100 kilometers above the surface of the Earth, and that all these trajectories were suborbital space flights that took the ice boulders through the vacuum of space. In addition to the ballistic equations, I had been looking at the geometry of the Carolina Bays. Some authors had described them as elliptical, and other authors had said that they were just oval. I started measuring the width and length of the Carolina Bays and overlaying ellipses with the same width-to-length ratios over them. The ellipses matched exactly. Time after time, regardless of whether the bays were small or large, the ellipses fit the bays exactly. I became convinced that the Carolina Bays were conic sections and that they could have originated as inclined conical cavities. I started to experiment to find out how I could produce conical cavities with ice projectiles. After trying different types of targets, I found that a mixture of equal amounts of pottery clay and sand with enough water to make it into a consistency of bricklayer's mortar worked well. I had to find out how the terrain of the East Coast could have been liquefied by the ice boulders to have created the Carolina Bays. At first, I thought that the extraterrestrial impact could have created shockwaves strong enough to liquefy the soil. At this time, I did not know the magnitude of the extraterrestrial impact, so this was a dead end. However, using the equations from Professor Melosh, I was able to calculate the energy of the impact based on the size of the Carolina Bays. A bay with a length of 220 meters, about the size of 2 football fields, was made by an energy of 13 kilotons of TNT, about the size of the bomb dropped on Hiroshima. This energy corresponds to an earthquake of magnitude 6.0. A bay with a length of 1 kilometer was made by an impact with an energy of 3 megatons of TNT. This is equivalent to a 7.54 magnitude earthquake. It was now evident that the saturation bombardment by secondary impacts of ice boulders had sufficient energy to liquefy the soil. By this time, I had a complete model of the mechanisms needed to create the Carolina Bays. I called it the glacier ice impact hypothesis to differentiate it from the Younger Dryas impact hypothesis proposed by Firestone. First, a meteorite impact on the Laurentide ice sheet ejected ice boulders in ballistic trajectories. The ice boulders came crashing down and liquefied the ground. The oblique impacts of the ice boulders created inclined conical cavities, and the tremors produced by the impacts reduced the depth of the conical cavities by viscous relaxation to produce shallow elliptical bays. I was very excited. I had developed a physics-based model for the creation of the Carolina bays, and I had a physical model to test the mechanisms. I knew that if I did not publish this, I would never get the credit, especially since I did not have a degree in geology or astronomy. My first book, published in January 2014, was entitled Killer Comet: What the Carolina Bays Tell Us. It was a short book that described the glacier ice impact hypothesis and proposed that the saturation bombardment by ice boulders was the primary cause of the megafaunal extinction. I knew that I had rushed and that I had not provided sufficient evidence to convince the critics of how the Carolina Bays were formed, but at least my idea was now public and I could claim priority. In the summer of 2014, I took a field trip to explore the Carolina Bays in South Carolina. I arranged the trip by asking my wife to spend the 4th of July holiday in Myrtle Beach. My second book, entitled Solving the Mystery of the Carolina Bays, was published in 2015. This book emphasized the elliptical geometry of the bays and had images of additional impact experiments and an estimate of the water ejected by the extraterrestrial impact based on thermodynamics. I mailed copies of the book to several prominent impact experts and researchers of the Carolina Bays. I sent a copy to Professor Mike Brown, who was my instructor on the science of the solar system at Caltech. I also gave a copy to Dr. Richard Carlson, the director of the Department of Terrestrial Magnetism of the Carnegie Institution for Science, where I had been regularly attending the weekly seminars. A few weeks later, Dr. Carlson asked me if I was going to publish in a peer-reviewed publication. With this encouragement, I started looking for a journal where I could publish the paper. The original title of my paper was The Impact Origin of the Carolina Bays. Several journals declined my paper because it was not quite suited for their subscribers. Thinking hard about the content of my paper, I decided to change the title to A Model for the Geomorphology of the Carolina Bays. I submitted it to the journal Geomorphology, and after undergoing the peer review process, it was published in 2017. Since then, I have created about 20 YouTube videos that explain many details and research ideas that I did not put in my books or in the peer-reviewed publication. I have classified these videos into 4 categories: the glacier ice impact hypothesis, the Aeolian lacustrine hypothesis of the Carolina Bays, the Younger Dryas extraterrestrial impact, and Carolina Bays research. The conclusion of my book, Solving the Mystery of the Carolina Bays, says that I feel very lucky to have come across the problem of the Carolina Bays after I retired, and that some professional geologist or astronomer should have developed this hypothesis instead of me. But unfortunately, the prevailing attitudes of the impact experts created an antagonistic atmosphere where the study of the Carolina Bays amounted to career suicide with no funding and no support from academia. Something that has given me the confidence to face off against all the professors and critics is the elliptical geometry of the Carolina Bays. The mathematical precision of the bays can be verified easily by anyone with LiDAR images and a graphics program. The lesson to be learned is that we, as scientists, should never be so arrogant that we think we know everything. Advances in science can only be made by observing nature carefully and remaining open to new ideas. I learned a lot from my new experiments and by answering questions about my YouTube videos. In 2020, I published a new book titled The Neglected Carolina Bays: Ubiquitous Geological Evidence of a Cataclysm. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.